What is this? A grapefruit satellite? These were the words of Nikita Khrushchev, who used to be Prime Minister or Premier of the USSR. He was referring to Vanguard 1, a tiny metal sphere that is still in the air today, orbiting around our planet. This little sphere was part of the Vanguard satellite program, and it was launched in 1958. It was really tiny, around 10 centimeters in diameter, and only about 1.4 kilograms or about 3 pounds in weight. Today we're going to be talking about Vanguard program and Vanguard satellites. Welcome to What the Math. Welcome back to episode 4 of History of Spaceflight, and behold the Vanguard rocket, the series of rockets that in between 1958 and 1959 launched or tried to launch a few satellites. Now, first thing you might notice right off the bat is that this rocket has no fins. Yes, that's right. These rockets were the first rockets to use no fins at all and relied solely on the gimbaling of their engines. So this is essentially how they turned, which is actually a very interesting strategy, but at the same time possibly was the reason why so many of these rockets actually failed. In the previous episode, I kind of briefly talked about Vanguard TV3, which was actually the third launch, or the third rocket that was launched and failed miserably right on TV. And not only was it an embarrassment and humiliation for the United States, it was also a huge boost for the Soviet space program, which essentially gave them a lot more confidence and a lot more reason to brag about Sputnik. Now, before we launch this rocket, let's actually go into the back into VAB and check out what's inside this beauty. So let's analyze this from the bottom up. So on the bottom here, the first stage was a liquid engine. It was a liquid engine with a very powerful gimbal, meaning that this was essentially how the rocket controlled itself and how it initiated the gravity turn. Then right here, we have our second stage, which was another liquid engine actually. And this engine would take us into upper atmosphere and initiate the final maneuvers before getting into a circularization orbit. And finally, behind all of this, we had our little satellite attached to a solid booster. Now, this solid booster was the last stage, and this is essentially what circularized the orbit, or actually that's the wrong word to use, because none of these orbits in early satellite launches were circular. So this was essentially to make it to give it the highest possible boost, so that it was actually it was a very elliptical orbit, but that was meant for the satellite to have as much life as possible, as much space life as possible. Now, the other thing you may notice when I remove this is that this satellite actually has solar panels. Now, this was the first satellite ever to have solar panels, and not only that, but it was the first satellite to actually successfully prove that you can use solar panels in space, and it actually functioned for 7 straight years. For 7 years, it was sending signals using these communitrons, or I guess radio antennas, and for 7 years we received its signal. So this was essentially the first successful solar panel satellite in space, and this was why this was actually quite a successful launch after all. Alright, 7 years might not sound like a lot, but it's actually, compared to the original satellites like Sputnik 1, Sputnik 2, or even Explorer 1, that only could transmit signals for about 20 to 30 days, it's a huge improvement. Essentially, this is like, we're talking about hundreds of times longer transmission than the early other satellites using just a battery, not the solar panels. Alright, so enough talk. We're gonna go to the launch pad and launch this beautiful Vanguard rocket and talk a little bit more about the Vanguard program as well. Alright, we're gonna wait a little bit until the sun comes up, and what we're going to do is, of course, use KOS yet again, because that's essentially how the early rockets were launched. Obviously not using KOS, but using a pre-programmed launch sequence, which would then transmit telemetry back to Earth and tell the astrophysicists and NASA scientists, actually that's the wrong word, NASA didn't exist back then, the space scientists, how the rocket was doing. So we're gonna type copy, and I actually made a special file called Vanguard for this particular mission, and now we're going to run the mission. But before we do that, I wanted to actually mention how the propulsion and telemetry worked in this particular rocket. So here, the first and second stage were actually controlled using something equivalent to KOS. So it was essentially a pre-programmed sort of a system that would control the rocket's ascent. But then after the second stage, the last stage, the solid booster only relied on one thing. And that thing was actually a pre-programmed stabilizer that essentially just told it where to point and where to shoot its engines. It was kind of very rough and very simplistic, but at the same time it seemed to have worked really well. So even though it was really simple, it was sort of like a shot in the dark, you know, where you're going to point this rocket, where you're going to shoot your boosters, where you're going to shoot your engine. And it seemed to have worked because the actual satellite is still orbiting in space today. But the telemetry system and all of the guidance system was actually present in the second stage right here, somewhere in the middle of this rocket. And it actually separated after the second stage and fell back to Earth. But the last third stage was simply controlled by a preset program. Alright, so let's run Vanguard program. And here we go. 3, 2, 1. Houston, we're ready to go and launch. We're going to set a little bit of a inclination right away, and for this particular launch we're going to be aiming at 35-degree inclination compared to usual 90 degrees that we do in Kerbal space program. This is going to be 35-degree inclination. And here I decided to kind of start my gravity turn a little bit early, and because this is a rocket that has no fins, it is really hard to control, and you'll see how much it's going to wobble in a second. You can kind of see my gimbal is already going crazy. And I wonder if this is why this program was so unsuccessful. Okay, I don't want to say unsuccessful, but out of 11 launches, 11 Vanguard rockets, not only 11, okay, that is actually not correct. There were 11 official launches, and there were actually a lot more test launches as well. But out of all of those 11, only 3 actually reached orbit and succeeded in delivering their payload. In other words, 8 of those rockets that were officially launched failed miserably. Not only did they fail, but they humiliated, American scientists. So Vanguard TV3 was actually televised on television. That sounded kind of funny, but yes, so it was actually broadcasted on television, and we've learned that in the last episode, we've learned that it got destroyed and it exploded right on the launch pad. Vanguard TV3 backup was launched maybe 2 months after that, in February of '58, and it failed after 55 seconds. So this was the third launch. This was actually on March 17th, 1958, and this was then renamed Vanguard 1. Officially, it was known as Vanguard TV4, but it was then renamed into Vanguard 1. All right, so here comes our first separation. This is the second liquid stage. And will be going into a higher orbit and try to reach our apoapsis. Now, the actual rocket reached apoapsis of approximately 650 kilometers, periapsis of 650 kilometers, so the lower part was actually very high, and apoapsis was about 4,000 kilometers. So its actual orbit was very elliptical, very elliptical, and very high periapsis, very high apoapsis, which is why the actual Vanguard 1 satellite is still in space today. It actually has not disappeared. It has not fallen back to Earth. It is still orbiting around Earth today, and if you have a powerful enough telescope or binoculars, you can maybe get lucky and even see it, although that's kind of unlikely because it's so tiny. It's literally the size of a grapefruit. Now we're gonna come to our last stage very soon, but we're just gonna wait for this rocket to finish burning, and I think it's going to increase our apoapsis to approximately 120 kilometers, which is the Kerbal equivalent of the periapsis that the actual rocket had. And so yeah, Vanguards failed miserably, and after the Vanguard 1, after this successful launch, Vanguard TV5 also failed, Vanguard SLV1 also failed, and this is only within a few months, and they kept failing over and over. So sometimes the third stage would fail, sometimes the second stage would fail. Then there was another launch, and second stage lost thrust and the rocket fell back again. And you know what, I gotta give credit to the American scientists for for just trying. They just would not give up. So after 8 launches, Vanguard 2 in February of 59 was actually once again succeeded. It was put into orbit, and it delivered a much larger satellite that was about 10 kilometers, sorry, not 10 kilometers, 10 kilograms in size, in mass. And that particular satellite helped us a lot with science. It helped us understand the shape of Earth, and we'll actually learn that Earth is not spherical as we thought. Earth is actually a pear-shaped object. Ooh, here comes the last stage. Yay! Separation. Here comes the last engine. This is a solid booster, and this is my grapefruit in space. I'm gonna wait for it to get into apoapsis of 119 kilometers. All right, I undershot a little bit, but that's okay. And we're gonna use the booster to circularize, or to get as much apoapsis as possible, and then separate the last part as well. Vanguard 2 showed us a lot about Earth, and then after Vanguard 2 there were 2 more failures in 59, and then Vanguard 3, the last of the program, was launched on September 18, 1959, and on that date they were able to deliver a much larger satellite. It was 22 kilograms or 50 pounds in weight, and that satellite was, I guess, equivalent in size to Sputnik 1, but it had a lot of really successful scientific missions. It showed us a lot of things about air density, temperature ranges in our atmosphere, and also different sort of scientific things about micrometeorite impact on satellites. So we learned a lot about all that stuff just based on this interesting yet somewhat unsuccessful Vanguard program. Now, after the Vanguard 3, the American scientists decided not to send any more Vanguard satellites, and they realized the Vanguard rockets were not very successful, and they actually realized that Werner von Braun's rockets were much more successful. Even though they were meant for military, they were much more successful at launching satellites into space, and basically that's what they went for after all. And I personally think it was a good choice, because these rockets, they were kind of underbuilt. They didn't have specifications like the Soviet rockets, and compared to the Soviet rockets, Vanguard rockets were tiny. They were ridiculously small, and so the size may have actually influenced their failure rate as well. Now, Vanguard 1 was actually only the second satellite US launched, but ironically, this is the oldest satellite in orbit today. So this satellite, this beautiful grapefruit-sized solar panel covered satellite, is still flying out there, and that's actually pretty incredible. I mean, just to kind of think about that, after 57 years now, it's still flying around and it's still in orbit, and it's going to be there for another 200 years. It's going to take it about 200 years to actually decay its orbit and to finally crash back into Earth. And another thing that the satellite was able to test is the so-called mini-track system. Mini-track refers to the world's first satellite tracking system that US was developing, and it's a system that then was replaced by other military systems. But mini-track was really awesome because not only was it able to track satellites successfully, it was able to essentially determine, the range, the distance, the location of a satellite, and this was way before the Soviets were able to develop a similar system as well. But ironically, for mini-track, the first satellite that it was able to track was Sputnik 1. It was actually the Soviet satellite that it was tracking, not the American satellite, even though it was originally developed to track American satellites. Now, as we're coming to our final destination, I think we have maybe a few seconds left before we fire our last stage. I just wanted to kind of mention that why did US decide to even launch Vanguard program? And the reason why is it's actually kind of interesting. They chose to go with Vanguard and not with Werner von Braun's Juno program because, really for one reason, because they thought that this particular program, Vanguard, was meant for civilian use. And this was actually something they wanted to do because they thought that if we launch a civilian satellite, last stage, separation, yay! I think it's going to announce something here. Did it announce something? Yes, it said, Vanguard is now in orbit. We're going to be here for a while. Program ended. There we go. And so yeah, they actually launched the satellite because it was meant to be a civilian satellite, and that way they could actually show the Soviets that, you know, we can put satellites in orbit. It's not a military product. You don't have to worry too much. We're going to just put a bunch of these satellites in here, and then they were actually planning to use them as spying devices, and which obviously they're using today, but originally, that's what their plan was. Put a bunch of civilian satellites, have them spy on the Soviet Union, nobody gets upset, everyone is happy. But little did they know that the Soviets launched satellites first, and they used the military rocket on top of that. So all of their planning, all of their decisions to go with Vanguard and not Juno rockets were completely useless. They essentially wasted years of development trying to develop this satellite system or delivery system called Vanguard, just because they didn't want to upset the Soviet Union. Well, anyway, so this is my grapefruit in space. I believe I can control it a little bit. No, I can't anymore. Okay, yeah, it lost all of the control panels, so I can't control it anymore. But it does have a lot of energy left because we have solar panels, and in real life this functioned for 7 years. They were actually good for 7 years, and for 7 years we could hear its beeps or bloops or whatever the sound was. We don't actually know what the sound was because it's not as popular as Sputnik, so it's really hard to find what sound it was making. But we could but we could hear and detect its signals for 7 years. Vanguard 2, Vanguard 3 are still in the air as well. They're still orbiting, but this was the first and the oldest of them all. So this is the grandfather satellite. I guess Sputnik is the grandfather satellite, but this is the oldest satellite in orbit. So if you ever get a chance to use a powerful telescope and you get a chance to look into the sky and somehow detect where the satellite is, take a look, you might even find it. Anyway, so even though this was a somewhat failed program in the beginning, it succeeded at the end, and the 3 satellites that they launched were quite successful in acquiring a lot of awesome scientific information that helped us learn more about our planet today. Vanguard, despite its initial failures, was at the end successful. Hopefully you enjoyed this video, and hopefully you will subscribe and like this video as well. Watch out for more history of space videos coming up next week, and the week after that, and the week after that. Thank you so much for watching, and game you later, guys. This has been What the Math with Kerbal Space Program and the history of space program. Bye bye.